Today we're going to talk about the sine function, so I'm just going to do a few problems from the worksheet. Number 3 here says to find the amplitude and period of each sine curve and then write an equation for the curve. So we have to remember that our sine function, the equation is y equals a sine b theta. And remember that a is your amplitude and b is from the period. So what I need to do by looking at this graph is find the amplitude. Now you should remember that the amplitude is always the maximum minus the minimum. So my maximum here is at positive 2. My minimum is at negative 2. So my amplitude is going to be 2 minus negative 2. 2 minus negative 2 makes it 4, and then we always have to cut the amplitude in half and divide that by 2, so my amplitude is 2. To find the period, that's how long it takes to complete one cycle. So if I choose to start my cycle at 0, which is usually a pretty good idea, and if you look at this graph, 0 is a well-defined point. If we choose to start at this point in the middle, it's going to be hard to figure out what that point is and to try to figure out how far I need to go to get to another point that's in the middle. So it's always good to start at a well-defined point. Usually 0 is a good one. So I'm going to start at 0 here, so I go down and up and back down, so I end right here. So now I need to figure out how far that is. If this is 0 and this is 2 pi, and there's one increment in between, we must be counting by pi's. So this is 0, pi, 2 pi, which makes this point 3 pi. So if I want to get my period now, what I do is take the end point, which is 3 pi, and I subtract 0 because that's where I started. So I take the end minus the beginning, which is just 3 pi. The problem is I need b. You have to remember that the period of a sine function and a cosine function is 2 pi over b. So what I do is set this 3 pi equal to 2 pi over b. So I'll have 3 pi equals 2 pi over b. This is always a whole number, so it's over 1. So then I will cross multiply. So I get b 3 pi equals 2 pi. To get b by itself, I have to divide this side by 3 pi and this side by 3 pi. So 2 pi divided by 3 pi is just 2/3. So b is 2/3. And now I can write my equation because I have a and b. So my equation is going to be y equals a is 2 sine and b is 2/3 theta. And there's our equation. So from this graph I was able to find the amplitude, which is the max minus the min, and the period, how long it takes to complete one cycle. I found a and b using that, and then I wrote my equation. The next problems we're going to do are 7 and 10. On 7 and 10, the directions tell us to sketch a cycle of the sine curve and write an equation for each graph. Now I'm going to skip sketching the graph because we don't need to do that, but we're going to figure out how to write these equations first. And then we're going to do a problem later where we sketch the graph. So number 7 here, the amplitude is 2 and the period is 5. If the amplitude is 2, then that means a is 2. Period is pi, and again, what I'm going to do is set this equal to 2 pi over b. So I have pi equals 2 pi over b, because I have to figure out what b is to write my equation. Pi, that's over 1 because it's a whole number, cross multiply, I get b pi equals 2 pi. To get b by itself, I have to divide this side by pi. So 2 pi divided by pi is just 2. So b is 2. So b is 2 and a is 2. Now that I know those, I just write my equation. So y equals 2 sine 2 theta. Alright, let's do number 10. We're going to do the same thing. It tells us that our amplitude is 2, so we know a is going to be 2. But my period is pi over 4. Again, that means I have to set it equal to 2 pi over b, because that's what period equals. So the period pi over 4 equals 2 pi over b. Then I cross multiply. So b pi equals 8 pi. To get b by itself again, I'm going to divide by pi. So if I divide both sides by pi, I get b equals 8. Now that I have a and b, I can write my equation. Y equals a, which is 2, sine b, which is 8, of theta. Alright, last one is number 20 here. Now number 20, the directions say to sketch one cycle of the graph. So to make a graph, I have to make a table. So I have theta and a y, and then I just pick points for theta. Now, I usually go with increments of pi over 4. So I'll do negative pi over 4, 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi. Then let's jump to 6 pi over 4, which is 3 pi over 2. Now what I'm going to do, since I've picked those points for my radians, I just plug it into my formula here and figure out what y is. So the first one, I'll do 4, make sure you're in radian mode, I'll do 4 sine 5 times negative pi over 4. You should get 2.83. 0. So you'll take 4 sine of 5 times 0, which is just 0. And then we'll do pi over 4. So I take 4 times the sine of 5 times pi over 4, which is negative 2.83. Then I do the same thing by plugging in pi over 2. You get 4, 3 pi over 4, negative 2.83 again, pi, is 0, and 3 pi over 2 is negative 4. So now that I have a good idea of what my points are, I can get a graph. So, I draw my graph here. Again, I usually like to go in increments of pi over 4. So there's pi over 4, which means this is pi over 2, that's pi, this is 3 pi over 2, this would be 2 pi. Negative pi over 4, negative pi. Now I know my amplitude is 4 because of a here. So I go as high as 4 and go down to negative 4. Now I just plot these points. At negative pi over 4, I'm at 2.83. So negative pi over 4, 2.83, which would be right about there. 0 is at 0. Pi over 4 is at negative 2.83. Pi over 2 is at 4. 3 pi over 4 is at negative 2.83. So here's 3 pi over 4. So down here, pi is at 0, and 3 pi over 2 is at negative 4. Notice I skipped one here, so I'll have to make sure I account for that when I graph this. So my graph is going to look something like this. And off like that. Now my amplitude's off a little bit. Here, probably should go up to 4 up here, but that's alright. So now you can see that all I did was graph some points, pick some points, graph them, and then I can make a graph. I mean, that's all there is to it.